Hi everyone, my name is Ankur Patel. I'm a program manager with the identity team at Microsoft. We've been working on an incubation effort around verifiable credentials, and we're thrilled to share now it's in public preview. We can't wait for it to help change how we onboard users, secure access to applications, and help users recover in a more verifiable way while protecting privacy. With me is Matthias. Matthias, you want to introduce yourself?
My name is Matthijs Hoekstra. I also work in Azure Identity and I work in CXP, our customer and partner experience team. And together with Ankur, I've been doing several proof of concepts and pilots with our customers on verifiable credentials.
Thanks, Matthias. Let's dive in. When we talk to our customers, 92% of those organizations perform some form of ID verification today. Typically, it's done in the context of onboarding employees, contractors, customers, vendors, partners. Then a whole bunch of other credential verification takes place, such as multi-factor authentication or email round trips, etc., to gain access to resources. And then finally, there is loss of credentials, recovery. Typically, we rely on things like an SMS text or a phone call, even, right? The net result of this is it leaves a lot to be desired to be made better. So 82% of these organizations then said they would prefer a way that was safer, faster, and maybe even easier to do these forms of verification. Let's look at each of them a little bit more closely. When we think about changing landscape around regulatory concerns, while traditionally the identity systems have focused on ease of use and security, increasingly, as we want to verify who the user is, we are required to collect a bunch of personally identifiable information. And given the stringent regulatory concerns that are emerging beyond general data protection, GDPR out of Europe, or California's data protection laws, there is similar views being constructed all over the world to further protect user rights around privacy. Now, given that, it's very difficult for enterprises to keep track of all of this information and ensure the shifting landscape around how to meet these regulatory concerns. Now, furthermore, in order to reduce friction, application developers are forced to figure out how to do custom integrations, whether it's signing with some social service provider or federate with any other enterprise identity system. But each one of them requires custom integration work. It requires us to hang on to this personally identifiable information, further increasing that regulatory risk. And even if we do it, the time to achieve these solutions is not deterministic, right? From a user perspective, sometimes you upload documents and you wait 6 weeks. Or you ask your IT department as an enterprise developer to say, can you please turn on this federation? And who knows how long that takes. But every one of these things is a difficult thing to go do, both in terms of time that it takes, the complexity involved, and maybe even money that's involved. The end result here is that this is not as convenient to use as digital cards that we are used to using for our everyday life. And it definitely doesn't result in what customers seek as an ideal experience where you verified me once, please just give me access to my information, to my applications. So we challenged ourselves to think about how might this work differently. So we've partnered with open standards community to imagine a different way of this working. Let's take a look at demonstration on how might such a scenario like identity verification work based on open standards. In this scenario, we are onboarding a new employee. Now, given COVID and other change in digitization of these processes, onboarding people remotely or verifying their credentials remotely is fairly common. So let's imagine for this demonstration, we have received an email and we are Matthew Michael. We are on this list and Woodgrove wants to onboard us as a new employee. As is typical the case today, you've been asked, have you completed a background check? Now, in our case, we have done integrations with leading identity verification partners around the world to help our customers do such a flow. So in our example here, it's a fictitious company that we're going to visit, TrueID, that is going to help us do onboarding. Now, this is a trust ceremony. A company can decide what credentials or information they want to collect. Often we fill out a form and upload documents. So in this case, we are uploading a selfie and a government issued identification. But again, Woodgrove gets to decide what information is required in order for them to trust. And TrueID is going to do the verification. When we click next, TrueID is now able to match the selfie with the picture that's in the government issued document. And they're able to attest, therefore, that the person presenting this document is indeed the person to whom the government issued document was issued. However, one thing that's very different here now. Typically, a background check company would say, we will inform your employer if this information is valid or not, or whatever the result is, and it's kind of a black box to us. Versus in this world now, I as a user can scan this QR code using Microsoft Authenticator, for example, type in a PIN because this is a remote signing flow, and take possession of my own background check status. If I click on this card, I can now see the attestations that TrueID provided as a part of this verification process. They're able to say this is a valid government issued document. They're verifying and attesting to my selfie. They're able to say what my age might be or anything else that's appropriate. Upon doing so, I can go back to my employer and say I have completed my background check. And again, instead of doing some back channel data exchange, they are able to verify this information by requesting permission from me directly. And I can approve it using Microsoft Authenticator. Now, because I'm demonstrating this to you from my laptop and my phone, there's a QR code, but a mobile first experience will result in a deep link that you can click on directly instead of scanning QR codes. Now, upon verifying this information, Woodgrove gives me access to the employee portal. They have imported the information from the credential that TrueID gave, my name, my address, etc. Now, instead of issuing me a new username and password, I can continue my journey using verifiable credentials by typing in this PIN code, for example. That's my employee ID in this case. Once I accept this card, I can go do the rest of my onboarding tasks with the company, such as order a new computer. If I go to a retailer, in this case, a fictitious company again, ProSwear, typically we would sign in using a username and password. For developers, this is an OAuth-based federation. But how many such federations can a retailer set up? It's very complicated and it's not very scalable. In contrast, as a user can now be asked for, hey, do you have a verified employee ID card from your company? And if you can present that, and if your company is on the list, we get our discounts. The best of all, if I tap on these cards now and go to recent activity, I can keep track of what information I presented to whom, when was it issued to me. Over the summer, we'll introduce new features whereby the user can even restrict permissions to such use on an ongoing basis. So that's a quick demonstration of how verifiable credentials can be used. Let me bring up my slides again. So to summarize, Azure AD Verifiable Credentials can now provide us a better way. Not only Authenticator can be used to verify information in an easy to use manner, in a secure manner, but now it's more verifiable, transparent, and even convenient for the user to do all of these interactions in a consistent manner. Let's take a look at how this system works a little more closely under the hood. So the scenario we saw here is Woodgrove is the issuer of a verified employee ID card. The user is a holder, using Microsoft Authenticator as a wallet, but any other standards compliant wallet can also be used by the user. And then finally, the user can present such attestations or credentials to anyone, such as Fabricam. What makes this possible? So traditionally, the credential that is issued to the user is bound to an object ID that is owned and controlled by the issuer. This is why verifiers like Fabricam have to register their app with the issuer. This could be an Azure Active Directory instance, or it could be any social identity system. As a result, the user is not able to present such credentials to anyone they want, nor have control over correlation of such information. Versus in this new world, we are saying there are two keys. One key is used by the issuer to sign the attestation that says, I am attesting that this user is a verified employee of Woodgrove. And the second key belongs to the user. So they can present it to anyone they choose as a subject, and no one else can present this on their behalf. Compare this to a normal domain-specific credential. So Fabricam as a verifier can now independently check who issued this credential and who presented this credential. And the way they can do it is by leveraging this public key infrastructure. So when such keys are minted, The private key is securely stored by Woodgrove in their hardware security module or Azure Key Vault, for example. And corollary, the user is able to store their keys in their secure enclave on their device. The corresponding hash of the public key is published to a blockchain network so that any verifier can easily go look up based on open standards. So all of this work is based on these open standards. What you just saw is a user agent implementation. That's Microsoft Authenticator. That's what's used to manage these credentials. In a traditional identity system, there are three key things an identity system does. So instead of federating with the issuer, we're saying federate directly now with the user being their own identity provider. Now, even if you had these keys that are stored locally and resolvable, and that's what Universal Resolver is for, think of it as a DNS lookup for this new world where there is no centralized directory. DIDs are the standard way to express such an identifier, and it's a W3C standard. We will provide you a pointer to these resources in the appendix with the slides so you can go and look at the specifications on your own. Now, the credential format has been the other key place of interoperability. Typically, we've done these as OAuth or SAML scopes, and they're specific to a given domain. Versus in this new world, W3C has another standard called verifiable credentials to express this card. The card is a digital or a visual expression of it in Microsoft Authenticator, but other wallets can present them however they see fit. Now, these permissions for whom the credential was presented to is stored locally in a concept like an identity hub. Under each of these areas, we've given you the current stage of implementation and stage of publishing of these standards. And again, details will be available in the slides. As a result, the user can now present these credentials using things like OpenID Connect, which is what 96% of all applications on the internet speak, making it possible to issue and verify these credentials at some scale. If this is an area that's of interest to you, we highly recommend you join Decentralized Identity Foundation. This is where a lot of these ideas are discussed and invented, if you will. And then the ratification takes place through normal standards bodies such as W3C. Our implementation is an instance of that standard stack. So you would use Azure Portal to configure your credentials, the look and feel of it, the color, what you want to put as claims and assertions in it, etc. You can use our SDKs and APIs to request and verify these credentials. Matthias will take us through that here shortly on how to build these things. And then we would use Microsoft Authenticator as a user to manage the life cycle, receiving it from an issuer, presenting it to verifiers, etc. So let's get hands-on experience with help from Matthias to take a look at how to request and verify credentials from anyone and how do we issue credentials in a way that anyone can go verify it. So let's dive in. Matthias?
Okay, thank you, Ankur. So let me show you how to build an application and which can take any verifiable credential and verify if it's the correct one, and then take some kind of action. So I have Visual Studio Code here on my screen. And let me walk you through a few of the building blocks so you understand what's going on. It's a Node.js app. And we do some, including of the library we provided to the developer here. We set up some information. There's some config file which has to connect to our key vault. So the first thing I have to do, and this is coming from our GitHub sample, which we will refer to at the end of the presentation, is set up some crypto work. So we are telling the SDK how to sign and the messages we're going to send to Authenticator. Yeah, Ankur showed you that the presentation, how the architecture works. We are using private keys to sign messages. This is how we tell the SDK how to get to them. Then there's a definition about, well, what kind of credential I'm going to ask for. In this case, I want to build an app which asks for the True ID. And part of the application is, well, I have to ask for the right credential. And the next step would be I have to validate that I actually received the right credential from the right issuer. The credential type I'm interested in is True ID. And I know it has to come from this issuer and this specific identifier. So Ankur mentioned that the decentralized identifier is what we use. Well, this is the unique identifier from the True ID company.
And then Matthias, we will cover it later in the issuance section how to get this, right? Because as a
Correct.
verifier, I need to know how to find the identifiers for the issuer. Okay, sounds good. So let's come back to that. Let's keep going.
So again, then I just set up some of my node stuff. So it's going to website, I'm going to listen to a certain port, etc. I'm going to use a session to store some information, and then I'm going to publish a web page, and the web page has some JavaScript in it. What I will do inside of that JavaScript is call a method in my Node app, so I can actually show something on the screen. The first thing we do as a developer is I have to prepare a request, which I can then send to Authenticator to instruct it what to do. And that request can be represented as a QR code. And we tell Authenticator, download the request here because it's kind of a big request, and a QR code is kind of limited in the amount of information it can display. Or it's using a deep link, as Ankur mentioned before as well, if I'm on a mobile device. But so I have to prepare that request first. And this request is a OIDC SIOP request based on a standard. And what it contains is information about wallet. I want you to present to me this type of verifiable credential. And that's what I'm doing here. We have a so-called requester builder. We give it some information. We tell it, if you have information, please send it here. That's the redirect URI, which I specified here. So if the user accepts to present the verifiable credential to me, it will be sent to this address. I ask it for the true ID schema type. That's the constant I configured upstairs on top on my on my code. And what we can do, and this is optional, we can also tell Authenticator, if you do not have that credential, you can get it here. So this is more like a better user experience. If they might not have done the flow like Ankur just demoed, you can just point them directly to there, and they can get the credential anyway if they don't have it.
Now
So that's
that's
it.
super important. Sorry to interrupt you, but that's kind of super important, right? In today's world, if you wanted to do it, the moral equivalent would have been you have to sign up over here. Versus in this system, we can say, no, go to the best suitable authoritative source to go get this credential. Here's where you can go get it from. And so, as a relying party or an application developer, I'm just focused on my stuff. Cool. Let's keep going.
Yeah, it's kind of, you don't have to build a sign up button anymore, right? You just ask people to sign in, and if they don't happen to have the credentials you're asking for, they can, inside of the app, actually get those. So it's kind of a nice experience. So after giving all that information, I create a request and I store it in a session. I create a URI which I will send back to the web page. Like, well, this is the address where you can download this specific request because it was so big, right? And it always points to this specific format like OpenID / VC. This is what Authenticator understands as if it's in a QR code or if it's in a deep link.
And the other thing I noticed here, like it's cool where most developers understand OpenID Connect protocols. It also seems like we're leveraging Java Web Tokens, which is another key concept that developers who are building identity-related flows understand. Can you elaborate a bit on that?
Yeah, so that's the thing, right? If you start diving into the details and you want to actually look at what's going over the wire, the request builder, what it actually does is just build a job according to a specific format which is specified in that standard. So the form in the job is like the instructions for Authenticator. This is how to do it, and everything going between Authenticator and my verification website is signed. So when I create this request, the SDK reaches out to Key Vault, retrieves and asks, well, can you sign this message? So the signed message will be, which is in JOT, will be signed with the signature of the verifier, will be sent to Authenticator, and Authenticator can then validate, look, you asked me to share some personal information. I really want to make sure that it's actually you, right? So it's kind of important to know who's doing what. So that pattern you described, like public-private key, which is not new in this world, right? I think the difference here is that anybody can get to your public key all the time. So it's really easy to validate messages. That's the pattern we are using everywhere.
So I store the request in a session and I send back to the website, look, here's the URI. There's a JavaScript function which creates a QR code, and the QR code points to presentation request.jot. That's this guy here. And then Authenticator will just download that request. What happens next is, okay, as a user, I go, well, here's my credential. I accept that it's being sent back to the relying party. So the second thing you always do, first one is just building the request, send the instructions to Authenticator, is accept that request and make sure it's actually correct. This is the response part where I can validate the sent credential. This is done here. We have a validator builder and we tell it, well, I accept this credential type, true ID, from this issuer. I also want to make sure what's actually meant for me. Please validate that. And what the SDK will do for you is make sure that this verifiable credential, the signature from the holder is correct, because I know it was meant for Mark, and is it actually issued for Mark as well? That's one check. It will also check the signature if it's coming from this True ID company, which I trust, etc. So all that work is done under the covers. It will try to resolve the DID from the issuer. It will resolve the DID from the holder. It will retrieve the public keys from that IAN network, and then make sure all the validations are done. And if it's done, I say, well, I'm good, and then you can do whatever you want. So let me just show you how this looks like and actually prove it works.
So as you run it, sounds like this 3 lines of code is really the heart of it, and it's doing the work of requesting it, verifying it, doing all this check, and then you get success, go on and do your application logic. So all that magic is in those 3 lines.
Yeah, man, and I know I always make the joke a little bit, but when your engineers build those SDKs and all this code, and for me just like a few lines of code and all the complexity, because doing the right signature checks and make sure it's all safe and secure, that's a lot of work. So I'm kind of happy that you all have removed that for me. So I'm using a reverse proxy to make sure I have a secure tunnel to my work machine. This is the website I just showed the code for. I ask it to create that. Let me just go back here. I asked to create a QR code. That's the code I showed first, the request builder. It creates a QR code. And if I hover over it, you can actually see the URL, OpenID, VC, blah, blah, blah. I scan it. It asks me, well, do you want to present True ID? I do. Request is approved. And I say, yep, the True ID is actually verified.
So that's pretty amazing, Matthias. That was by a completely different party. The question is though, because this is standard space, instead of relying on just possession of one username and password, what if we could ask for more than one credential and therefore rely on multiple trust issuers? How much work would that be?
Yes. So I knew you would ask this. So I actually have to have this prepared. Let me show you. It's not different than I just showed you. It's just a little bit of additions. Let me get to my other project here. Here it is. So again, it's the same app. I just added a few lines of code. So what I added, well, here's the credential again, right? True ID from this issuer. I added a couple of other credentials. I want to use an employee card, and I want to use a specific certification. So again, I just configure those. I go back to the request builder. The rest is still the same. The thing I added to the request builder is not just ask for one. I'm gonna ask for 3 credentials here. So I added these 2. That's it. So that's the only code I changed. Obviously, I have to validate those as well. Again, look, go back to the validator so you know what I did here. So what I added here is like, I want to validate that credential 1 is coming from issuer 1. Credential 2 is coming from the other issuer, and the other credential might come from another issuer. Maybe they come from the same issuer. In my case, I got like 2 different issuers sending out these credentials. And I validate, and that's it. Okay. Yeah, let me run the app and show my phone. and my browser again. So same application. Again, I'm going to create the QR code with the special request this time, right? Scan it. And now you can see it's asking for 3 credentials. I ask for my True ID, my verified employee card, and a verified security analyst certification from White Hat. I allow it, so I will send 3 of these credentials now back to the website, and the SDK, the validator, will actually validate, make sure all the signatures are correct, etc.
And now that means this application is able to establish trust with 3 different issuers all in one go. And then when it meets its level of assurance, its proof,
Yeah.
they can let you in and do whatever it does.
Yeah.
Super cool. Before we go to issuance, in fact, how about we take a look at what you can do with the information that this application received, the attributes that were in the credential?
So again, this is the same application, and what I did in the validator is the SDK is actually doing the validation for me, right? It knows that all the signatures are correct, etc., etc. What I have to do as a developer afterwards, okay, I just received those 3 credentials. I know they're correct. They're signed by the right folks. It's coming from the right holder, etc. I can actually just get information outside of those credentials. So I can retrieve those 3 credentials from that message from Authenticator. Again, a signed job with all the signatures correct, etc., etc. And I can write logic, for example, to, well, this is in this case access to a high value resource. I want to make sure it's an employee. I want to make sure the person has the right certification, and it's really the person, right? So I did an access verification, ID verification, and I want to match those two. So what I can actually do is I retrieve the first name from the True ID verifiable credential. I can also retrieve the information from the employee card. And typically I would write code, well, look, if these two are the same, allow access is true, and I do whatever I need to do in my application, right? So quickly show you that actually is working, and I can retrieve those information. So let me refresh the page. I'm gonna scan the QR code again. Again, it's asking for those 3 credentials. Yeah, and I read like I know that the first name, last name, it's all validated. It's with the same, but True ID. I know I'm older than 21, and I got the right training credentials. So yeah, that's pretty much it.
All right, Matthias, can we take a look at how to issue credentials?
Yes. So as you said, this is an Azure service. So I'm in the Azure portal, and I have a storage account and a key vault already set up. And my verifiable credential service is running here as well. So when I go to credentials, I can create a new credential. And it asks me for a name, which subscription I want to use, but also the display and the rules file. So what are those? Well, we documented those. The display file is about the credential. How does it look? With a logo, we got some text, some other information. It's a JSON file you have to provide so you can create the credential. I actually created one for a employee card. Let me show you which one. So I have a display card here for Woodgroove. There's a color, there's a logo, and I'm telling I want to collect the first name and the last name for this credential. The second file we need is the rules file, and this is part of where we tell the system, okay, collect these proofs or attestations in this way. In this case, I'm going to use an ID token. I have to tell it what the OIDC well-known endpoint is. I'm going to use Azure Active Directory, and I have to specify client ID. I'm going to tell the system, look, I want to have these scopes that tells the system what kind of claims you're going to return in the ID token, and I'm going to map family underscore name, given underscore name to the claims inside of the verifiable credential.
Now, compared to other traditional flows, sounds like this allows me to control this logic again in the application layer instead of further down in the identity stack. Is that fair?
That's correct. Yeah, that's correct. So I've uploaded those 2 files. Let me select them now from Azure Storage. I got the display file. I got the rules file. I have to give it a name. This is an employee card. And I create a credential.
So what happens when we click create?
The system is combining those two files and actually creates the credential. And here's the URL, and this is the one I have to copy for my application in a minute. So if I open it up, you can actually see this is what the system generates. This is what Authenticator downloads and to understand what kind of attestations it needs to provide and send back to the servers.
So then we have to go update our front end app now?
Yeah, and I have the issuing app here, and it's like almost the same code as the verify app I just showed. I'm gonna replace this contract with the one I just created. I'm gonna tell it I want an employee card. Again, I'm hosting this. Remember the requester builder? It's the same. I'm gonna tell you I want this credential type. And here's the contract of the credential URI of this credential type.
The credential type will be employee now, right? Instead of expert?
Yeah, and I think I changed that here already. Yeah, here's employee.
But down below, we still have expert.
Oh, that's the ID. Yeah, let me just change that quickly.
Yeah. Great.
Does it really matter? Yeah, so it's the employee type, and here's the URI of the credential. And the one thing I changed is allow issuance. This tells the wallet that it needs to get this credential and not present it. And then I do the same thing. I create the request. We create the QR code. It's been downloaded from the specific from the session again, and that's it. Okay, let me quickly show you the app running. It's on board, and I got an reverse proxy running here, and let me bring up my phone screen again. So now I can just get credential again. The credential builder creates the request. I can just scan the QR code, and then you see I accepted the card, and now I have the card, my employee card in the wallet. So that's how easy it was to issue a employee verifiable credential.
Thank you, Matthias. That was super cool. We just covered how to request and verify credentials as well as issue credentials. So you can use these scenarios to do things like secure application access, right? So for example, what Matthias showed us on being able to request multiple verifiable credentials would allow you to say, I want to know that you're a verified employee of this company. You are the person to whom we issued that credential, and that you have the appropriate certification or compliance training before you get access to some application. And the user can keep track of what information they presented to whom for what purpose. Similarly, you can even issue those credentials to existing employees. They could sign in with existing username and passwords that Matthias showed during the issuance demo. And when you receive a verified employee ID card, now you can use it not only to access line of business applications, but even beyond the company boundary. We believe such an approach can help make access more trustworthy, faster, and cheaper to implement, while retaining high degree of trust and maybe even greater control for the users. We've been working on private preview with many customers like Caio University for issuing student ID cards and doing verification on campus and beyond campus, or with National Health Service in the UK to enable faster staff onboarding, or with Government of Flanders on helping citizens start new businesses very quickly. We're so excited to see how many different scenarios customers are coming up with and implementing these scenarios so quickly. Some of our public preview customers have tweeted and blogged about saying that they are able to go from watching a video such as this and implementing it in a few hours, compared to typically how long it takes. So here are some key resources that we would like to share with you. DIF, DIF, Decentralized Identity Foundation, is at Identity.Foundation. This is the industry working group. More than 180 companies are part of it now. Our white paper that shows the North Star of where we're going. What you just saw is implementation of the first chapter, if you will, to get started. The white paper discusses a more broader vision. DID Explained is a marketing video, 2-minute video that gives you a quick overview on YouTube. And then there's a developer walkthrough, a compendium to what you and I just walked through now with Matthias. And then there's a developer documentation that Matthias showed on doing the issuance process, but there's also documentation on how to request and verify credentials. And then some of the more detailed technical topics on things like scaling and performance or recovery are covered in some more detail through our blog series. We strongly recommend you following that if this topic is of interest to you. So thank you very much for watching this session. And Matthias, thank you for joining on helping us demonstrate how to use these credentials to not only verify and enable trust processes at scale, but also to issue credentials so your customers, your employees, and your partners can use them for so many different use cases. We're super excited to see what customers will build with this technology. We look forward to your feedback and hope the session was valuable. Thanks again. Enjoy the rest of the Build conference.